can assist you or tutor you more. If you have more questions, just email me. So question 66, right, it says determine the horizontal and vertical components of force at pins A and D. Right, this is a frame question with two force members. So first step is find global equilibrium, just like we're doing trusses, but I don't think we have any force that's would allow us to do that. And so which we move on to the next one, right? Because we can find moments at A, and that would be in E. It's all unidentified, but eventually we'll get there. So now we have to blow these things apart into its own components. So dB is 1, ABC is 1, and E is 1, right? But dB is dB over here. This is a two force member, right? This is a two force members. And as we remember during trusses, right, drawing a section like that, we can just simplify this. You see? We can just simplify these two forces as one going in that direction. Because remember, we doing the truss bisection, right? If we cut it, right? These are the only thing we need to draw, right? Especially this forces, because this is a two force members. So, so we only have to draw A, B, C, and components E. So let's get started. Here is the components A, B, E. A over here, B over here, and C over here. And here's a force going, you see over here it's going, it has to go this way, right? So if this is going this way, this force must be going this way, because the force can't go this way, right? It has to go down. And if this is going down, so then on the next picture or the components, the force must be the opposite of the first one. So this force is going back up. And let's draw the components of E first, actually. Right, two force going back up, this force going back down, right, at 12 kN. So if these two forces are going up, right, that means this force over here is going down, and this force is going down. And here's like a wheel. Oh, wait, sorry. The wheel has to be a lot bigger than that. Oh, what the heck? Alright, let's say this is a wheel. Right. I draw a little bit too big, but you guys get the ideas. And here's the tension going into this direction, right? And so if all forces are going this direction, the normal force of A, well, it's always going this direction. And since we don't really know what A is, so let's just assume that A is going back up. Alright, going back up. So now let's solve for each part, right? And well, let's use the E over here first, right? E is pretty easy to find. So some of the forces in the Y direction going back up is positive, equal to 0 for system E over here. So this is 12 kilonewtons, and let's just call one of the tension is T2. So this is also T2 because they're the same, right? Equals T2 times 2. Therefore, T2 is 6 kilonewtons, right? So if this is, so that means this is 6 kilonewtons, and that means this is 6 kilonewtons, and that means this is 6 kilonewtons, right? And now we can move on to this for this member over here, using the sum of the moments at A, right? Get rid of the two unknowns. Let's say going this way is the positive, right? So the force dB, this thing equal to 0. Force dB is going into a clockwise rotation. That means it's a negative. So dB is a negative. And remember, we're using the force in the y direction, right? And looking over here, this is 1.52. So if you times 2, the x and y distance by 2, 3 and 4, and this is a 3, 4, 5 right triangle, right? So that times 4 over 5 and times the distance, which is 1.5 meters. and plus this force is going this way, so it's creating a clockwise. Wait, sorry. dB is creating a counterclockwise. I'm sorry, my brain froze for a second. It broke down for a second, and this force is going into a clockwise direction. So this is negative 6 kilonewtons times, there's the altogether, this is 3 meters, right? 3 meters, and minus this force is going in this direction as well, clockwise. So it's 6 kilonewtons, and be careful, right over here. Here's 0.3 meters, so it's 3 plus 0.3, so it's times 3.3 meters, right? And this force over here is creating a counterclock direction, right? It's going this way, and the distance from here to here, that is 0.3 meters. So plus 6 kilonewtons times the 0.3 meters, right? And here we go. Let's simplify and solve for dB. Plug everything into your calculator. dB. Can't find the paper where I've done it. So let's do this real quick. 6 times, well, let's see. So here and minus this, right? So this is really just 6 times 6, because this minus this is, well, because this is 0.3 and this is 3.3, so it's just times 3. These two are the same, all negative, so it's just 6 times 6, right, equals 36. And go and move these two whole thing to the right side of the equation, becomes positive divided by 1.5 times 5 divided by 4. dB should give you 30 newtons, right? dB should give you 30 kilonewtons. And now we have dB. We can find what these two forces are, right? So now we can use the force some of the forces as C to find some A forces. So some of the moments at C. So that would be AY. Well, okay, so now here we go. If we're using C, right, this force had to counteract this force. Since this force is going back up, this force has to go down, right? So now we know AY has to go down to counteract that, to allow this whole beam to be in equilibrium position. So AY is going back down because dB is going back up. So AY times 3 meters, right? And it's going back down, so it's going to create a counterclockwise direction, so it's positive, and minus dB times the this direction, y direction, so it's 4 over 5, and times the distance 1.5 meters, and this whole thing will give you a equal to 0, so AY, plug everything into your calculator, that should give you 12 kilonewtons, right? So AY is equal to 12 kilonewtons. And some of the forces in the x direction, right? Some of the forces in the x direction on the bigger beam going to the right is the positive. Therefore, there's AX minus BD times 3 over 5, right? And minus 6 kilonewtons of this force over here going to that direction. And AY should give you 24 kilonewtons. AX should be 24 kilonewtons. And then, since this is a two force members, so dB is going to here, is going to equals to this and this, right? So dB times 3 over 5, that would be the x direction, would be equals to dx, right? And that should give us 618 kilonewtons, and dB times 4 over 5 equals dy, and that should give us, what is it, 3624 kilonewtons. So dy is 24 kilonewtons, and dx is 18 kilonewtons. And here we go. This is a little confusing when you first start doing frames, right? It's a little different than trusses. It has many multiple force members, but once you have, plan everything out, break everything down into pieces, and working step by step in a very chronological and logical way, everything will just eventually be solved. So yeah, be patient with these questions, and yeah, good luck on your studies, and see you in my future videos. Bye. If you have more questions, specific questions you would like me to do, please comment in the comment section down below.